Okay, take a seat, get comfortable, because you're about to embark on a journey way back in time toward eternity. Because as strange as it may seem, your life's trajectory is so much more complex than that of orbiting bodies, than celestial mechanics. While no one can predict your future, the same may not be true for the future of the universe and everything in it. By looking at the laws of nature that govern them, we can see the future of distant futures reflected in them, and we can begin to predict them, in part. So here's their story. After the light goes out for us, the matter that once made us up will continue to exist, and the stars will keep on shining. 2,366 years have already passed, and Halley's Comet is making a grand reappearance in the inner solar system. Some 10,000 years later, the red supergiant Antares will turn into a supernova. The star, monstrously bright, becomes visible in the sky, even in full daylight for our descendants. And the Earth continues to spin on its axis, slower and slower, slowed down by the tidal effects caused by the presence of the moon, at a rate of 0.02 of a second per century. So in 50,000 years, we'll have to add 1 second to the length of the day. 1 second more per revolution of the Earth later. For the so-called astrologers, things are beginning to get complicated, because the movement of the stars moving in our galaxy has eventually transformed the celestial vault, where hundreds of new constellations are now taking shape, into a sky that looks nothing like the one we know today. 200,000 more years have passed, and the Voyager 2 spacecraft is passing near Sirius, currently the brightest star in our sky. We've now surpassed the point where Earth has likely been struck by an asteroid larger than a kilometer, considering the frequency of impacts. And after 1,000,000 years of enduring the hardships of time, being eroded by the rain and wind, the Great Pyramid of Giza, like all stone buildings of today, is beginning to become almost unrecognizable. On the moon, all the footprints left by the Apollo mission astronauts have now completely vanished, erased by cosmic rays and other space erosion phenomena. And it's somewhere out there, in these thoroughly altered skies, that a second little sun appears for a few weeks. The red supergiant Betelgeuse has just exploded into a supernova. Now easily visible in broad daylight, the dying star for several weeks rivals the full moon in brightness at night. And in a sequence 450,000 years later, the star Sharp 710 passes close enough to ours to disturb the Oort cloud, sending dozens of comets towards the inner solar system. Millions of years pass, and the Earth's crust continues to move along its lines of fracture and weakness. The opening of the East African Rift now forms a new ocean basin between the Horn of Africa and the rest of the continent. Australia is migrating northward. California is separating from America and 3 times further away in time. We find Mars adorned with rings. They were formed following the disintegration of the small moon Phobos, battered by tidal interactions caused by the red planet. These structures are thought to remain in place for between 1 and 100 million years. On our planet, the ground continues to move. Africa's collision with Eurasia closed the Mediterranean Sea. Volcanoes rise and crumble, mountains are thrust up, others vanish beneath the relentless blows of time and erosion, until, in a giant jigsaw puzzle, all the continents end up fusing into one. 240 million years have elapsed, and our solar system has now completed a full circle from its current position around the center of the Milky Way. 60 million years later, Saturn is no longer the Lord of the Rings. The dust and ice forming them have all been degraded by the ultraviolet radiation from the sun, and the plasma generated by repeated collisions with micrometeorites, captured by the magnetic field and gravity of the gas giant, they eventually plunged into it. And doubly far into the future, the apparent size of the moon on Earth is now too small to completely mask the sun. It has now become impossible to witness a total eclipse of our slowly brightening star. And already things are getting seriously complicated for all of life. The increasing intensity of the sun has increased the erosion of surface rocks, eventually trapping air's carbon dioxide in the soil. Meanwhile, the plate tectonics of our aging planet have wreaked havoc. Volcanic activity gradually ceases. Without volcanoes to recycle carbon into the atmosphere, CO2 levels drop drastically, until photosynthesis becomes almost impossible for nearly all plants. For those who might be there, it's high time to think about leaving, which is still quite irritating. 200 million years later, free oxygen and ozone have totally disappeared from the atmosphere. On the surface, all multicellular life forms have gone extinct. And now the sun's brightness is 10% higher than it is today. The average surface temperature is now 50 degrees, and the oceans have begun to evaporate, gradually turning our world into a true sauna. On the surface, only a few basic life forms might still be resisting this hell at the poles. It has now been 1 billion years since the Voyager 1 and 2 probes were launched. They are likely still drifting through space, 25,000 light years from their origin. And the data etched onto the 2 golden disks they carried after being battered by cosmic radiation has become impossible to read. 1,300 million years later, Earth's outer core had cooled sufficiently to solidify. Gradually, its movement ceased. And with it, Earth's magnetic field, deprived of this protective shield, any hypothetical remaining life forms found themselves subjected to the deadly bombardment of high-energy particles from our Sun. In the skies of that era, the Andromeda galaxy hurtling toward us at a speed of 140 kilometers per second became distinctly visible to the unaided eye, now larger in size than the full moon. Another 500 million years have passed. The surface temperature of the world hovers around 150 degrees Celsius, and our blue planet is only blue in name. Except for perhaps a few single-celled colonies, banished to very high-altitude lakes or subterranean caverns, nothing here can survive. On Earth, life is extinguished. The distance from Earth to the moon has become too great for the moon to have its stabilizing effect. The tilt of Earth's axis becomes chaotic. 600 million years later, Triton, one of Neptune's moons, also disintegrated under the tidal forces of its gas giant. After spending more than 3 billion years without rings, our solar system sees the blue giant take over from Saturn. In the heavens, a gentle, diffuse collision with Andromeda begins. Cast into a strange dance, the 2 galaxies merge their clouds of gas and dust. From these contests and influences, hundreds of millions of new stars will be born. And this chaotic ballet is not about to stop, for it will stretch over nearly 3 billion years, until ultimately only one giant galaxy remains. It has already been given a name, Milkomeda. And it is in this environment, painted with the light of new stars, that in 5.4 billion years, the death of ours begins. After depleting its hydrogen reserves in its heart, our sun leaves its main sequence and begins to transform into a red giant. At the end of this phase, our star has become 2,700 times brighter than it is today. And in its expansion, by multiplying its radius by 250, it has vaporized Mercury and Venus and is licking or even engulfing our planet, charred by the one that allowed it to be born. And barely 100 million years later, all that remains in the center of the system is a tiny white one dot, barely legible. A dying star, a white dwarf, compressing 50% of the sun's mass into a volume little larger than Earth. Around it, the surviving planets keep revolving. Now the star is surrounded by a planetary nebula, vast gas sheets expelled from its outer layers. In the center is the remnant of a dead star, cooling inexorably, growing paler and paler. To finally not be able to see it anymore, we'll have to go twice as far in our story. And here is our late sun out of the visible realm, transformed into a black dwarf. Its surface temperature has dropped below 2,000 degrees Celsius, and visually, the remnants of the star have died out. The king is dead. Long live other kings, for even then, in 1,000 universes across the whole cosmos, billions of stars keep populating the sky. Some are newly formed, collapsing from clouds of gas. They have just lit up on their own. Other massive ones die in dantesque explosions. Some even smaller, older ones just continue to shine as they always have. And the tens of billions of years that follow remain bathed in their light. Yet inexorably, the deep sky is emptying. For the universe is also aging, and in doing so it is growing, expanding to the point where the stars located beyond our local cluster are gradually turning red, moving too fast, too far. They fall into oblivion for us, forever. For hypothetical inhabitants of these future worlds, the cosmos has visually become an island universe. All the galaxies located beyond our local boundaries, passing behind the cosmological horizon, have become inaccessible to their eyes. But in the galactic neighborhood, the mergers continue, bringing new stars into the sky each time. And after 450 billion years of colliding and merging, the 50 or so galaxies that currently surround us end up forming just one hypergiant, within which, slowly but surely, the gas clouds are drying up. Because even though when stars die, some matter can be ejected into space, where it can continue to contribute to the formation of other celestial bodies, the vast majority remains trapped in their dying hearts. Thus, over time, each sun itself becomes a small fuel prison. Unstoppably, all over the universe, galaxies are depleting their fuel and their luminosity is declining. The formation of new stars has now become extremely rare. Until the moment comes when the universe is 1,000 times older than it is today, the very last of them lights up. We have just entered the degenerate era. No more gas clouds will ever light up. Sun after sun, the universe empties of all its light. The giant galaxies now only contain small, low-mass stars, known as red dwarfs, some of which are still capable of shining for over 1,000 billion years, which is as long as the universe's age at that point. But though we once believed stars to be immortal, we have learned that none are. And when the universe is 10 times older, the day will come when the very last star goes out. Visually turned into dark bodies, all the kings will be dead. And time continues to tick away. The universe continues to exist. The cosmic clock keeps ticking. Growing older by 1 second every second, it's still young compared to the time to come. And the inky black skies are not entirely so yet. In each giant galaxy, for 100 billion dark bodies, there are actually an average of 100 active stars. Because when you have eternity before you, the improbable can only happen eventually. These were formed as a result of extremely rare collisions between two extinct celestial bodies, which occasionally, by colliding, merge and reignite. Even rarer, binary systems of dead stars circling each other can collapse. From their fusion, novas can be born, which with their ephemeral flash dispel the degenerate air's darkness for a few weeks before everything plunges back into darkness, until such an event repeats before no more ever occur. In this now total darkness, however, there are still bodies, remnants of brown, white or neutron stars, and black holes. All these stellar remnants continue to revolve around the galactic center. Their paths intersect, they brush each other, and sometimes destabilize each other. The lightest celestial bodies, the frozen planets, who escaped the death of their star and still revolve around it, are the first to suffer from these gravitational disturbances. Everywhere in the universe, the passage of compact stars in their vicinity will eventually disrupt the stability of their orbits to the extent of tearing them away from their system. As for the few surviving planets of this cosmic billiards game, they will eventually see their orbits as worn out, to the extent of ending up crashing into the star at the center of their system, stars whose temperature continues to fall. Most have long passed the stage where you could touch them without burning yourself. Their surface temperature has fallen below that of your refrigerator. The sun is less than 168 degrees Celsius, and in the universe nothing happens for a short eternity. To see something interesting again, we need to fast forward until the universe is 10,000 times older than it is at this moment. And after thousands of billions of years of trading orbital energy, speeding up, it's now the turn of the most massive drifting stars to get ejected from their galaxy. The majority of them thus wander off into the cosmos. While a small portion, survivors of this cosmic billiards game, see their orbit as tired and over time, end up diving towards the supermassive black hole that sits at the center of every galaxy. Fueled by its stellar remnants, it temporarily becomes the site of gigantic explosions of matter and radiation. In the long run, this will be the destiny of all the stellar remnants. And when the universe is 1,000,000 times older than it was when the last stars went out, the galactic structures have been totally stripped away, and the clock is still ticking. We have entered the era of the Big Chill, and the universe, which is still only an infant compared to the times to come, is now nothing but a vast field of dust, rocks, and drifting stars. Distant futures are always a bit at the beginning, but don't leave, because what is starting to look like a never-ending story may be hiding millions of happy endings in the end. What happens next will depend on the stability of something within us, matter itself. Because even if heat, light, and stars have exited, the atoms themselves are still there, still part of the game. As cold and solid as it is, all the elements are still very much present, and to know what awaits them, we need to look at a question. Are the building blocks that make up matter eternal or unstable over the extremely long term? And even if no one has ever seen an atom die, maybe the universe will. If the protons found in the heart of all atomic nuclei turn out to be capable of dying, being unstable, then to give you the short version, after durations estimated from 10 to the power of 34 years to 10 to the power of 43 years, one after another, the protons will disintegrate, and with them, the matter, now incapable of structuring itself, will disintegrate. All that's left, drifting stars and wandering planets, rocks and dust, all, absolutely all matter as we know it will disappear, emitting in passing a meager quantity of energy, the only one available in the universe, to the point where a frozen star with the mass of our sun releases only an amount of energy comparable to that of your switched-on microwave. Which, let's be honest, is still quite a bit, and the time continues to spin until, after something like 10 to the power of 40 years, the universe becomes so cold that it falls below the temperature of the black holes themselves. From then on, these will begin to evaporate, and light will make its comeback. It takes the form of violent episodic flashes that originate from the darkest existing objects, because this peculiar evaporation process ends for every black hole, in the shape of Dantean explosions, which briefly disrupt the long-time darkness of this spectator-less theater. These episodic flashes continue until the last of the black holes disappears. Left are only elementary particles unable to bind, and photons extremely diluted and weary. In a space where nothing is created, nothing happens, we have entered the dark air. From now on, silence is the only object of which its nothingness is sound. The temperature is flirting with absolute zero. The universe is thermally dead. It has nothing left but eternity. Those who, let's be real, always do too. But don't leave. Hope is always what dies last, because there could be a different fate. If the proton turns out to be stable, then jackpot matter has not yet had its last word. It is still present during the era of black holes, and when the universe reads 10 to the 65th power years on the meter, all the things they still constitute start by tunneling to arrange themselves in an exotic way, which gives matter a liquid appearance then much later. Until the last black holes have evaporated. In the face of infinite durations, although very improbable, even the slightest probability eventually happens. Occasionally, matter sees the nuclei of its atoms fragment or merge spontaneously, altering their atomic structure, to strive for maximum stability. And at the end of a process, spanning from 10 to the power of 500 years to 10 to the power of 1500 years, all matter was transformed into iron, the most stable atomic element in the universe, which is not the most stable state of matter. Is a neutron mass much more stable? That's why, on inconceivable timescales, through the tunnel effect, stars, planets, and iron dust transform into neutron mass. Mass that collapses into black holes which subsequently evaporate, and this scenario, like in the first one, after clinging to it for many years, has since. For a long time, my tired imagination has been overwhelmed, and as the universe reaches 10 to the power of 10 to the power of 66 years, matter disappears. Indeed, it always ends up like iron. The expansion continues, and assuming that talking about time still makes sense forever. Cut. Except this final clap may not be the end. In suspension, it could be the starting point for new stories. Rolling action. It will take as long as it takes, but it will take time. It's not what it lacks, it's all the universe has left. And there will come a day when it will be 2, 4, 100, 1,000 times older than it is at this moment, and even then, time will continue to flow. And what can happen will inevitably happen. There's a theory that when the clock hits the surreal figure of 10 to the power of 10 to the power of 10, 56 years later, parts of the universe that have become sufficiently empty and cold could reach an energy state even lower than the vacuum we are familiar with. Descending to this level of exotic energy would result in a rewrite of the laws of nature in these regions of space. Different laws that, through inflation, would give birth to something new. New universes by the thousands, by the millions, an infinity of other universes. Perhaps it has already happened, that ours comes from it. Perhaps it will happen again, over and over, this time definitively, for eternity.